Hi, welcome back. Today we're going to look at table calculations. They're the fourth and the last type of calculations we're going to look at. Previously, we looked at simple calculations, eight functions, and in the last session, we looked at LOD expression. Well, today we're going to look at table calculations. And if you're anything like me and you came to Tableau with a background in Excel or any sort of spreadsheet calculator, table calculations ought to feel pretty familiar. First, just a word about me. If we haven't met before, my name's Jim Dehner. I'm one of the Tableau Visionaries. I'm also a forum ambassador, and I co-lead the Tableau newbie user group. And if you're not a member, come out and join us. We have a great time out there. You live in and around Nashville, love to see you at the Nashville Tug. You can join that also at the same time. Well, let's talk about what tables are and what table calculations are. What we're going to use in most of the examples here today is the Superstore data set. And I use that because it's the same data set that you got when you got your copy of Tableau. And when we talk about in tables and table calculation, we're talking about the table that you see on the screen and the underlying table, or the table, what we call the data table for the particular worksheet. And that data table is formed when you put dimensions on the rows and columns and filter those dimensions. It's a subset of the total data set. If we were to open up this hamburger looking icon here, the view data, you can see what the total data set is that we entered into Tableau here. The Superstore data set contains about 10,000 records, okay? 10,000 rows of data. Now, what you see on the screen is not 10,000 rows of data. And if we were to look there under the Analysis tab, there's another View Data, and we'll check on that and open it up, and you can see that that goes 12 rows of data in 3 fields, and these are the 12 rows of data. And you say, well, Jim, those look like 3 rows. But if you look at the way the Tableau looks at the data, as a long, tall, narrow uh, table, that's 12 rows of data. Okay. Now, in table calculations, much like you do in your spreadsheet calculator, we talk about direction and we talk about scope. Scope is how much of the table is used in the calculation, and direction is either it goes across the table or it goes down the table. If you think about what you do in Excel, you write a formula in a cell, you copy that cell, and then you paste it across the columns or down the rows. Well, that's the same sort of concept that we talk about when we talk about using a table calculation calculated across the table or down the table. One final topic we have to discuss before we get into the calculations is where in the order of operations table calculations are actually executed. I like to use this 10-step order of operations. I know there's a couple of different models out there, but this is the model that I use. You can go back to segment 4 and take a look at the entire segment devoted to the order of operation. It's that important. You really should spend some time with it. But in anybody's model for the order of operation, table calculations happen last in the sequence. And that sequence, in my sequence, that's step 10. And being last in the order of operation, they can use the result from any calculation that precedes it. It could be a fixed LOD, or it could be using sets, or it could be used in an include or an exclude statement, or a simple calculation. You can take the results of all of those and use those in a table calculation. The reverse is not true. You cannot take the results of a table calculation and use it in any other calculation. You can't use it in LOD expressions. You can't use it to find sets. They just plain haven't. The table calculation hasn't happened yet when sets are determined or when the fixed LOD is calculated or the like. There's one additional thing you have to think about with table calculations. Table calculations are dependent upon the data table for the worksheet that you're working on. And as a result, those results are unique to that table. You can't pick them up and take them and use them in some other table. That data table is totally different. So you can't take the results of a table calculation and put them on a summary sheet or anything like that. It just plain doesn't work. Well, let's take a look at the table calculation syntax, and then we're gonna take a look at some examples of how you would use table calculations. All of them start with a keyword. This one is a window sum. See window sum or window average or running sum, that sort of thing. It's a keyword that tells Tableau, okay, perform this function. Then that's followed inside parentheses by the first argument is the measure that you're going to use the function on. And that measure has to be aggregated. Think of the data table itself. We just looked. We went from 10,000 records to 12 records. There was a lot of aggregation that went into that. So it's in this case, we're looking at the sum of a measure, and then there's two other arguments. There's a start and a finish. And that pertains to how much of the table that you want to use. It's what row or column are we going to start at, and what row or column are we going to end at. And you'll see examples of how this is done. And let's just dive into one right now. Let's look here at this simple example, and I want to take a look at window sum. That's the calculation we've been looking at, and let's look in detail at what this is and how it works. Now, if ever you want to look up table calculations, you can look them up here in the drop-down, go to table calculations. You can see all the list of table calculations. There's just a whole lot of them there that you use. The window functions are probably the ones you use most, maybe ranking and then running totals next. But let's take a look at window sum. And what we're going to do here is window sum is the function, and our expression is sum of sales. You know that in words, let's just go to the sum of sales column, which we've got right here, sum of sales, and starting at the first record and going to the last record, sum those values. Now, what this expression tells Tableau is I want you to use the sum of sales to aggregate to go from the detailed data to the visual table that we're looking at. And then once you have those individual values, I want you to start at the first record and sum all the way through the last record, first record and the last record. How do I know if I'm going across or I'm going down? Well, here's our window sum. We can open the drop down and we can edit the calculation. And you can see here, I've got the show calculation assistant checked off, and I'm going across the table, and across the table is the go, going all the way across the table. Direction is across. So table across is the scope and the direction. Okay, we could look at table down, or we could look at table across, or we could look at any combination thereof, and we can change the way that we're actually performing the calculation. But right here, we're looking across the table. So looking again, what this calculation says is go to the sum of sales, and here we're looking at consumer, go across the table and take those four values for the 2018 through 2021 and get that total, and I want to use it in each location. And the corporate value of 706, I want to use that in each location also. And home office at 429, I want that in each location. Well, I could have used something else. I could have taken the window average. Okay. And it would look something like this. Now, this looks an awful lot like the same expression. What we've done is we've told Tableau take the sum of those 10,000 records for each combination of year and segment, and that's that same values that we looked at. And going from the first to the last, that sounds all the same. But in this case, I don't want the sum of those values. I want the average of those values. So this 290 is the average of these four values, the 266, the 266.5, the 269, and the 331. That's the average of those four values. And this 176 is the average of these four values. So we're taking the average of the sum of those values. And likewise, I could have taken the sum of the average. We could have looked at this. We could have said, well, let's take a look at the averages And first, I'm just going to change this here. I'm going to go over to the measure value, and I'm going to open this up. And instead of looking at the sum, I want the average of those values. And I want it to total using the sum. I want to total using the sum. Okay. And when I do that, I've got the average value. These are the average for each year. And I want to take the sum of those across the four values. So that 908 is the sum of those four numbers. You can see that value right there. The 921 is the sum of those four averages. So what you can do, and what you do is you use this first argument to aggregate the detailed data, and you use the function itself to decide what you're going to do with those individual values that are in the table. Let's take a look at a couple of other things that we do here. I want to take a look at the running sum. Okay, Jim, window sum, the running total. Take a look at what this tells us to do. What does it tell Tableau to do? It says, we'll take the sum of those values. These are the sum of the values. And starting at the first record and going to 0. Well, 0 is the cell that you're at. And I want to sum from the first record to where I'm at. So this is equivalent to the running sum. What it says here is this value is the sum of that value plus that value. This value is the sum of all three of those values from the first to the cell that I'm at. And this is the sum of all four of those values. This would be a 2-year total. And this would say, take the sum of sales going back one column and adding it to the current column. So this 532 is the sum of that value and that value. And this 563 is the sum of that value and that value. And the 628 is the sum of that value and that value. Go back one value and to the current value, take the total of those two values. So you see how that first and last affect the range, if you will, okay, the scope of the calculation. The direction is still across, but we've changed the scope. We've narrowed the scope down to just those two values. Okay. Now, there's something else the table calculations are used for, and they're used to navigate the data table. If you're familiar with offsets in Excel, it's kind of the same idea. It says, starting at this row, where do you want me to go and what do you want me to do? Well, there's 5 navigation functions that you can use in table calculations. It's first, last, index, lookup, and previous value. First is the first row or column in the data table, depending upon whether you're going across or you're going down. Row, columns. Okay. Last is the last row or column. Index just starts counting. And going to the right across columns is positive, going to the left is negative. Going down is positive, going up is negative. So columns are 1, 2, 3, 4, 5, but it starts from where you are in the table. Lookup simply says, go to this location, go from this cell to another location, and return the value that's there. We're going to take a good hard look at some of those. The previous value says, right where I am, go to the previous value. Either go up or go to the left and return that value. Let's take a look at how some of that might look here. I want to take the window sum as a running total. Here's the window sum as a running total. And this is the calculation we looked at before. And this is what I want the total. I want to be the running total, but I want to use window sum to do it. So I'm taking, this is the sum of those two values from the first value to the current value. This is the sum of the three values from the first value to the current value. Okay, well, what about previous value? Why don't I just take and add those together? Well, let's see what previous value did. If we remember, we said previous value says, look at the cell that you're at and take the immediately preceding value. So what previous value is going to do is it's going to, and start in the first cell, there's nothing preceding it. So it's going to return that same value. And now in the second value, it's going to take, it says, I want the value that immediately preceded the cell that I'm at. Well, that's at 266 again. And in the third column, it's that same value again. It's the immediately preceding value. For the corporation, for the corporate value, it's 128, 128,000, 128,000. It's the immediately preceding value. Now, we can use the previous value as a running total, and there's a way of doing this. And this will tell us how to do it. If we want to calculate the running total or the running product, there's a way to do it. We take the sum of sales plus the previous value. If you remember what we were doing here with the previous value always being the same. Well, here I'm taking the current value plus the previous value. So here it's the current value plus the previous value, and it's going to return that 532. And I'm going to take the current value, which is at 296, plus the previous value here being that value, the 532, and I get the 829, and so on. And I get the 1.16. And I'm calculating the running total, but using previous value. And you say, well, why would I want to do it several different ways? Well, I'm going to show you some examples where it makes sense to do it in use different functions to get the value that you want. Okay, now what I'd like to do is I'd like to show you another example calculating a running total and a running product using previous value. We're going to start with a very simple calculation using index. I wanted to show you how to use an index in this chart. And all index is going to do is it's going to count the number of rows or the number of columns, and it's going to increment by 1 for each row or column. And our index here is calculated across the table. So you see we get the values 1 through 4 in each one of our segments. Now, what I want to do next is calculate the running total. And the running total is nothing more than this calculation. It's the same calculation we looked at just a second ago. It takes the index plus the previous value of the index and totals them. So this value is the sum of 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. We'll take the running product, and the running product, same type of calculation, except instead of adding them together, we're multiplying the previous value by the index. So we get 1 times 2 is 2, times 3 is 6, times 4 is 24. So you see, we can calculate a running total or a running product in a number of different ways. So you might be saying to yourself, Jim, why are you doing that? Why are you doing a running total? You showed us an easier way to do it than doing this. Well, you're going to find yourself in situations where you need different options available to you to calculate a running total or to calculate a running product. Let's take a look at a couple of real-world examples that come up quite frequently. And this first one involves calculating the top end. And we're going to take a look at the top end within category by subcategory. So we want the top end subcategories within a category. First thing I wanted to do was calculate I just wanted to create a parameter so we could change the value of n. I've got it currently set at 2, and it's an integer value, and that is right here where it's easy to get at. Okay. Then I made a table. I made a table with category and subcategory and the sum of sales. And I've come back and I've created a calculation here. And this calculation uses a ranking function. And ranking functions are one of your best friends. Whenever you need to calculate a top end or find out sequentially, uh, values that are greater than one another, I like to use ranking functions. You can use index. You can use ranking functions. If you use index, understand that you need to sort higher to lower or lower to higher before the index is going to get you the top or the bottom in values. Ranking gets you around that situation because ranking will look at the actual value and not the position in there. Rank in all its forms, and it comes in several different forms, are table calculations, comparing values across records in a table. So we have to use a table calculation. And the calculation is simply we're going to take a look at the sum of sales and we want it in descending order. Okay. And I have changed that to a discrete value and placed it on the chart so that we could look at it right here. It was 1 through 4 in furniture, 1 through 9 in office supplies, because there's 9 values in office supplies. There's 9 subcategories in office supplies, and 4 in technology, 1 through 4. Now, I need to come back, and we've got the value of the sales, and I want the running totals of those values. I've added those to the chart here. I've added the running total. Not just me, but I like to look at it this way. I've got the running total and it goes from the top to the bottom. But what I really want is the running total within each category. Now we can do that by opening up this value, say edit table calculation, and we'll come down and we'll look at the specific dimension we're calculating at the subcategory level. And I want to restart every category. So now when I do that, I've got furniture, values of 328 through 91,000, the total, and the running total is 742. And then it starts again by category, 223 all the way down through 719. And then it starts again in technology, 330 for phones all the way down through 149. And the total, the running total is 836 for that category. Now, what I'd like to do is I'd like to do this formula. And I'm going to, this is a conditional statement. And you'll see I've taken the if statement, if the running total descending, that's this column. That's the rank of the running total. That's this here. If the rank of the running total descending is less than or equal to my top end to that parameter, then calculate the run, then show us the running total. If it's equal to the parameter value, show us the running total. If not, show us a null. We're going to drop that on our chart, and that's not doing exactly what we want it to do. So what we're going to do is we have to open this table calculation again, and we need to restart that every category. And when we do that, we've got our n equal to 2. So this is the value we're looking for. It's that 535 number, it's that 427 number, and it's that 519 number. But that's all I want to see on the chart. But what I'm going to do is I'm going to create one more calculation, and this is a Boolean. And this Boolean says, look, if the value here, my ranking, top end ranking is less than or equal to that parameter value, assign it true, otherwise assign it false. And we're going to go ahead and do that. And I only want to see the true values. So now when we do that, I've got a column here now that shows me the totals, and that column is dependent here. We could look at the top 3 values, or we could look at the top 4 values. And we can get our total for the top end values. Another example that comes up on occasion is calculating the consecutive occurrences of value. And in this case, we had some donors to a charity, and there's three of them, and there's John and Mary and Robert. And they made donation on an annual basis, but they didn't always donate. It wasn't uh, every year they donated. And this person wanted to know consecutive years of donation, and they didn't care about the amount. They just wanted to know uh, how many how many years in a row had each person donated, and what was their max. They wanted to find their most frequent donors over a period of time. So I've got a table here where I've got the each year they were donating, and I've got their names, and I've got the amount that they donated. And I came back and did a calculation like this, and all this does, this is a lookup calculation, and we're going to look up in the current cell, and if the gift value in that cell is greater than zero, assign a one. If not, assign a void. And we can do that, and it looks like this. So we can see that John donated in the last 3 years, missed a year, and then 2 years. And Mary had donated in the first year, and then in 2020 and 2021, and so forth. And we can see when Robert donated. Well, that's not what we wanted to know. What we wanted to know was we wanted to know consecutive years of donation. So we can do that. And this equation gets a little bit busy, but it's the same idea. If this, and I'm going to look up again, if when I look up that, it's greater than zero. So it's either zero or one. If it's greater than zero, then I want to take that value and add the previous value to it. Okay. And if not, then I want to substitute a zero in. So what I want to do is I want to stop and take a look here, and I say, well, look, if that's one, if that's a value greater than one, then take the previous value, which is zero, and add one to it and return a one. And if this one is a one, take the previous value, which is going to be, and it's going to make it a two. Well, let's take a look at what that calculation looks like. And that calculation, it looks a little strange. It looks quite a bit like the first one. That's because, and we're going to take a look, it's going across, and we want it to go down the table. Now, when we look at the calculation, and we've got it calculated direction-wise in the right direction, we see that it is returning a zero for this first year. John did not donate the first year. In 2018, he made a donation, so that was his first consecutive year. In 2019, it was his second consecutive year. In 2020, he missed, so we went back to zero. And we do that by calculating this, take the value in the value, and add the previous total to it. You can see John had 3 years in a row. Three. Mary, her max was two, and Robert was three. Well, I'd like to find out for each of them what their maximum value was. Well, we can do that with another calculation, and that calculation is a window max. It's another window calculation, and all it says is return the maximum value that you see, and we're going to go down by columns to get the maximum value by year. And let's get them in a good order here. And we don't want to go across. We do want to go down the columns, and we can see that it's 3, 2, and 3. And you say, well, that's fine, but that's not really what I want to see. I don't want to see it like that. I just want to see the maximum value. Well, now we're going to do some table cleanup. What we're going to do is we're going to use a last filter to just show the last column. If last equals zero, then show me those values. Else, hide those values. Okay? And I place that here on the filter shelf, and I've selected show and not hide. If I show hide, you can see that I've got all the values. If I show I've just got the show values. Okay, and the show value is the last value, the 2023 value. I don't want to see the year associated with it. I can just see those values. I can just hide the 2023. So, what have we done here? We've taken a look at using the previous value to count consecutive years. And then once we've determined the consecutive years, we've taken a look at those values and determined who had the maximum value or the maximum value by each person. I've got one more category I want to show you, and this has to do with with uh, table statistics. And this question comes up, and it seems to come up a lot with standard deviation. People want to calculate the standard deviation, and they say, well, I want the standard deviation, and I'm looking at the subcategory, and I've got the subcategory sales, and I want the standard deviation, and I can't get a value that makes any sense. And they take a look at at just doing a standard deviation. There we go. That's the one I was looking for. Yeah, they just do this. They take a look and they say, I want the standard deviation. And standard deviation, as well as other statistical functions, come in two different types. They come in a function that works at the detail level of the table, or they come as a table calculation, looking at the higher levels, at the aggregated level. Well, the standard deviation function looks at the detail level. It's running the expression on a detail level. So when I bring the standard deviation to the viz, I get a value that looks like this, and it's 700 and 335. And I'm just going to keep this value, and I want to go to this table and see if I can open this up. Always a danger. We get a value of the 334. And what's actually happened there is Tableau has gone out and calculated the deviation of all the values that make up those $167,000 worth of sales. So that's a standard deviation of the individual values that go into creating that 167,000 value. And if we were to take a look at the order count on that, we would see there's 755 values that went into calculating that standard deviation. Now there's another calculation, which was the one that most users really wanted. They say, I got this row of numbers. I want the standard deviation of these 17 values. Well, that's done with a table calculation. And the table calculation is very simply this. It's a window standard deviation. And you can see it comes in two different types. And we've also got the window variance, and we got the window median, and we got the covariances. So we can calculate the standard deviation of those 17 values using this formula. And when we do, you can see that the value is 102,940. And of course, it's the same for every subcategory. That's what the standard deviation is. It's the standard deviation of the array. So if you're going to use window statistics, or you're going to use statistics, you need to understand whether you want the statistics based on the individual record data or the aggregated data that you see in the table. If you want the statistic based on the aggregated level, use a window function for a table calculation. If you want it on the detail level, don't use the aggregated table calculation. Okay. Well, thank you very much. That's what I wanted to share with you today. I hope you have a better understanding of what table calculations do. They can do an awful lot of things. The only way you're going to get better using table calculations is by using them. So go out and practice with them. Use them in your the next opportunity you have to create a viz. All of this information is on my blog at jimdehner.com. It's also this workbook's available on my Tableau public site. Thank you very much. Bye now.